Hey guys, thanks for tuning into CMTEQ channel. This is embedded system programming with the STM32 microcontroller. Now in this tutorial, we're going to continue where we left off from the previous tutorial. So if you are not familiar, this is the STM32 CubeIDE, and we are using the HAL drivers to write our code for our STM32 microcontroller chip. So in the previous tutorial, we wrote this code here, and as you can see on your screen, this code is blinking the LED. Okay, so if you are not familiar, I'm just going to recap it quickly. So we basically created the main function, right? And in our main function, we made a call to the STM32 main header file. So that is in here, defined for our HAL libraries. Okay, and then we came into the main function, we created a while loop, and then we created a function GPIO config, and in this GPIO config, we did a configuration for all our pin out. We did the configuration for our GPIO where the LED is connected. So as per the schematic of this particular board, we found out that the LED is connected on port A, specifically pin 5. So we made a use of the struct to then initialize our port and specifically pin 5 and made it to be as an output, right? And then we pass all those parameters, basically these two parameters, into the initialization function here. And then all of that is then being called here into our main. And then when we get into the infinite while loop, we then execute the toggle pin function. So that basically toggling between high and low and delaying a certain delay here. Now the delay function is just being executed by a for loop that just wait for a moment while it is counting up to 500,000. So that briefly our program, and we've got function prototype here. So what I'm going to do now here, before we move into the topic of this tutorial, I'm just going to take this include file, the header file, and my function prototype, and move it into my main.h header file. So I'm going to basically just cut it like that, and then I'm going to paste it into the main header file like that. And now if I build this program, there will be errors. The reason why is because there is no longer the header file, and my function prototype will be missing as well. So if I do not want that problem, I have now to reference or refer the main.h header file into my main. So I'm just going to say include main.h, right? Because main.h will be containing all these, all the main header file and my function prototype. Now if I build my program, it should build without errors. Okay, they just finished building and there are no errors. So I can also just try to load it in to make sure that it's actually load without any problem. Now it's launching the ST-Link debugger and it should connect. Okay, there it's flashing. And we just need to load our program. Alright, successfully downloaded. Everything is fine, and we can see the LED is still blinking, so which means everything is still fine. Okay, so now we can then move on into the topic of this tutorial. So in this tutorial here, now I want to include the button function. So we can see the LED is just blinking without stop here. So now I want to control it now using the button. So what we want to do is either the LED might be in an off state, and if I press the blue button, then the LED should come on. And if I release the button, then the LED goes off. So that is one way of adding a button function. Now, the first thing to do here is we have to do another configuration. Just as we did the configuration here for GPIO A, pin 5, where our LED is connected. Now we need to do also a configuration for the GPIO port where our button is connected. So as always, if we look back into the schematic here, we will see that user button, okay, is connected to PC13, right? Via this jumper SB17. And then the way it is connected is that the button in the current state we start touching it or pressing on it is being pulled up. So if it is being pulled up, that means the registers inside are registering a 1, which is a 5. So the moment I press it, it will register a 0 because it will be pulled to ground. So now I need to now configure my button or my program so that it can record the action that will be happening on the input of PC13. All right. Now this is just a schematic, but you can learn more about this board by going into the manual of your Nucleo board. That's where they actually specifying a lot of the functionality, the hardware layout, the schematic, the hardware layout of this board. Okay. And then you have a reference manual that talks about the registers and the functionality of this chip, how to program and address them. Now, since we are using the HAL drivers, it makes things much easier for us because we can just call in the specific functions and definition as per the drivers here. And that is much easier to implement. So without wasting any further time here, I'm just going to now make a duplicate, okay? The duplicate of what? Of the configuration function, because now this is a function that is configuring the port for the LED. So I'm going to make a copy of this function, right? Just copy it and then I paste there. So now I've got two functions, but now I need to make them different. So this one is going to be GPIO A config and this one is going to be GPIO C config, right? And now here I need to change, okay, and I need to go into my main header file here and also then make this one a, okay, since I'm also going to be needing a function prototype for my new function. So then I need to change also to C. Now everybody's happy there, right? Now I can come back into my main.c, right? And then here I need to do some changes into the second function, which is a GPIO-C configuration. Now, the main changes I need to do here is the RCC register that is taking care of the clock. Well, the enabling of the clock for that GPIO-C port. So basically, all I need to do is to just change also the A to the C. So that basically means I'm now enabling the clock for that port. That's a peripheral clock that you need to enable in order for that GPIO port to function. All of these information are available into your reference manual. It is important to go through them so that you get a good understanding of your microcontroller board. I now move on. I have to do the same thing that I did here, right? And create a variable, okay, using this struct here. And this struct, we saw that it is defined into the GPIO header file, right? Let's see if we can open it. I believe that is where the struct is defined, right? So this is where the struct is defined and it gives us all the pin, the mode, and the configuration. So as by using that variable struct and creating our own variable, we can then make access to all the functionality of that struct, right? So we doing the same thing into our GPIO-C configuration function. So I'm just going to now change here to C, as always, to make sure that they don't clash. Then the pin, we're now going to change it to GPIO pin what? 13, because it is PC 13. And then the mode, we want to initialize this one as an input. So we have to set it as an input, and the reason is because it will be reading the state whether the pin is being pulled high or is being pulled low. So it must be set as an input so that it can read that condition. Now if we go back into the struct here and we go to the mode, because we already took this pin 13 and we find the mode here, there is a first option here is say GPIO mode input. So I'm going to copy that and I'm going to come here and basically just paste there. So that means we are now using the input mode. All right. And then the next thing is we need to also define the pull configuration. Now, as we can see that this PC13 is actually being pulled high, as I've already said, via the VDD with the 4.K resistor. It's being pulled high. When we action it, it will be pulled down. Okay, so which means we have an external pull going on here. So we then need to configure this pin so that it must not have an internal pull up or internal pull down, because we can also set the pull up or pull down internally. And that is defined also into our header file here. If you see the GPIO pull, you got a no pull, that is no pull up or pull down activation. And GPIO pull up, that means it's a pull up that is being activated, and pull down activated. So basically, instead of having the hardware pull down configuration, you can have the internal configuration set by software. So it's basically the same circuit built up inside. Right. Now we can say GPIO C underscore ini dot, and then we can select the pull option, right? And then we're going to say GPIO underscore no pull, and then we have a semicolon, right? Okay, so now the next thing is obvious. We need to pass these parameters, right, into our HAL GPIO init library. Now the HAL GPIO init function is defined into the source file here for our GPIO. So if we just bring this one here, okay, we can see that that function is located here. Okay, then we can open it. So if we open it, we can see that there is a lot of things going on into this function here. Okay, now if we were not making use of the drivers here, we would have been obliged to actually write this function ourselves in a way that will require us to understand the reference manual properly. Okay, so I'm then going to pass my two parameters for the function, so that it will be the port number, the GPIOC, and also the variable, okay, the GPIOC init, that is holding all my initialization. So that is GPIOC init. So the same thing we did here for port A, we've now repeated it here for port C, pin 13, where our button is connected. Okay, so the delay function, we leave it there. We might not need it at all. Now, let's see now what we need to do inside the while loop here. Now, inside the while loop, we then need to write the code that will be able to check the pin state or the condition on the input of the pin. We're going to make use of a simple if statement. So that will be if. Now, what are we checking? Okay, so we are checking the condition on the input of that PC13. So we have to make use of the read pin. So we must read the pin. Again, our driver is doing a good job for us. We have a function here that is reading the pins. So I'm just going to call it. So it's HAL underscore GPIO underscore, right, read pin. Now this function also need, I believe, two input. Now if I just place my cursor there, you can see I'm getting information from the IntelliSense here. It's telling me that I need to pass the port and I need to pass the pin. Okay, so it makes sense. So it's GPIO C, right? That is where our pin push button is connected. And then the pin that it is connected is GPIO underscore pin 13. So that's the only information this function need. Once the function get that information, I mean, let's look at it what it is in, right? So the function get that information. So it's basically going to check the state. You can see the bit status. So it's going to check the status and then it's going to action whatever condition it's going to be reading, right? So now we're going to be reading the return of this function, right? Because that function is returning something. Let me see what it is returning. It is returning the bit status, okay? So we want to read that status of the bit. So I'm going to say if GPIO read pin is equal 0, that means it is reading the 0, okay? Basically the state. What do I want to do? I want to toggle my LED. Okay, now why did I choose 0? Why did I choose 0? Because if we look at the schematic, okay, we can see that it is already being pulled high. It's already pulled high, so I'm not touching it, it's pulled high. Now when I press it, it's going to pull down. So which means when I press it, it's going to read a 0. So I now want to detect that first press, so which means I have to work with 0, right? So if it is equal to 0, then I want to toggle the LED of the PA port. Okay, so after we read the pin condition is 0, okay, now when you release, the pin condition goes back to 1. That means we will not execute this anymore. So what do we then do? Well, we need to put the else condition here. So we then going to say else, okay, if it's no longer 0, that means it is then 1. What do we want to do? We want to now reset. We want to now reset the pin, or basically just put it off. Because basically when we pressing it here, we will be toggling it. From whatever condition it was, it will toggle. But when we release, we just want to put it off. If it was off, stay off. If it was on, then you have to go off. So to write the pin, we then going to make call of the write function. So that is HAL GPIO write pin. Okay, and this function, just like the previous functions also, okay, he is accepting some parameters here. Okay, so the parameter is accepting is also the port, the pin, okay, and the state of the GPIO that you want to set it up. Okay, so the first one we're going to add there is the GPIO, okay, A, right? Because that's where the LED is. That's what we want to change. So then we're going to pass the GPIO pin, which is 5, right? And then we then want to change the state of that pin. So we want to reset it. So GPIO pin reset, like that. So basically this is the code we have. Now let's run this and then see what it is going to do. So I don't have to build it. I'm just going to run it straight because I know it's going to build before it's loaded into my microcontroller. Okay, we are done. Now we can see that the LED is on. Okay, so that basically means the pin PA5 is actually set. Now let's press the reset button first. You see it's staying on. So that's the default condition. Now let's see what will happen when we press the blue button. Nothing is happening. So are we actually reading our blue button? No, we're not reading our blue button. So what is the problem here? Now let's see. We now need to debug the code here. Something is not right. Okay, I see what is missing. We are not calling the configuration of the pin GPIO-C. We're not calling it. Okay, we've defined a function, but we are not calling it. So this is why it's not recording anything here. So we then need to just basically, I can just copy this, right? And then just change this to C so that we can enter both configuration of PA5 and PC13. Now let's run it again. This time around, it should work. Okay, so it is done. It is done. Okay, cool. So now we can see that the LED is actually off. Why is the LED off? We are not touching anything, but the LED is off. And that is because the pin state, okay, the pin state here is pulled high. It's VDD. So which means it's not 0, it's 1. That's why we fall automatically into the LCS. So it's put the LED off. Now for us to get this LED on, we need to put the pin state to 0. So that means I have to press here. You see? So when I press, then the LED is coming on. I release, the LED goes off. Now mind you, when I'm pressing, I'm inside the if condition here. Okay, because I'm pressing, so I will stay there. I will run, but I will just be in there because it's true. But it is now toggling because this is a toggle function. It is toggling, but we can't see the toggling because we do not have a delay. So now let's include the delay in just underneath there so that we can see it toggling on and off. So I'm just going to now come over here and basically just take a delay. Right, I'm just gonna copy and put a delay here. Then I will pass the value. So we want to delay for 50,000. Now let's run it again. Now this time around, you'll see that if I keep my finger there, this thing is supposed to be flashing instead of just being on, because it actually was flashing, but we couldn't see it. So let's see. Okay, now if I press it, you can see now the LED is flashing. Okay, so long as I keep my finger on, I'm going to be inside that if condition, and my condition will be true because now the pin is pulled down, so it's 0, so it will be just toggling. Okay, so which means if I don't want it to flash like that, or if I don't want to use the toggle function, I can actually just use the GPIO right pin and put it to set. It's going to stay on and it will not toggle. Okay, so that will actually achieve the same thing, but this is kind of cool because it's flashing. Okay, if we remove the delay here, it's going to stop flashing. But if we just want it to be on, we can just copy this function here. So we put it there and then we just comment out that one if we don't need it. So just toggle it. Then here we just have to say pin set. So what this will do is it will actually just set the pin without using the toggle function. Okay, but now this time around, even if we add the delay, it will not flash because it will just set the pin, it will not toggle it. All right, it is done. So now if I hit my button, it will just come on. It won't be flashing. It's because it's not using the toggle function. We're just setting it. We remove, it goes off. We press, it come on because we're just setting it. Now, if I include my delay here, okay, you guessed it, it's still not going to flash. It will just stay on. It will just stay on because we are not using a toggle function. It's just a set function. Now let's try it out. Okay, so now if I press it, you can see it's not flashing. Even though I have a delay, it's not flashing because we are just setting the pin. We're not toggling it compared to the toggle function. So that is it, guys. This is how you can manipulate your port using this read pin and the write pin and the toggle pin function. So thank you guys for watching. If you like this tutorial, please give a thumbs up and subscribe to CMTEQ channel. Stay tuned for the next tutorial where we actually going to see the latching. When you press the button, it stays on. Even though your finger is removed, it must keep a state. And when you press again, then it must go off. So we have to make a small adjustment into the code so that the pin can actually register the state. Okay. And then when we press the button again, then it registers the state and then do another action. So that is it. Until next time, stay tuned for next tutorial. Cheers.